presentation, I want you guys to follow these few rules, as we are going to be talking a lot about chemistry. And throughout my presentation, I do have a few rules, is that I want everybody to please stand behind your black and yellow line that you see out here on the floor, for your safety and for mine, as we are going to be working with some cold substance today. So, now, I'm going to be asking a lot of questions, so you guys can answer simply by raising your hand or by shouting it out, especially since we have a small group. So, I'll be calling you guys out by the color shirt that you guys have, or sweater. So you guys, if you guys see that matches the same description, if I were to say, my friend with blue, you're my friend with dark blue, so you're the one that raised your hand, right? Okay. So, my first question for you guys is chemistry. When you think of that word, what's the first thing that you think of? No? Anything?
Yeah.
Have an answer? No? You can be anything that you can think of. Chemistry. Have you heard of this word before? If not, we're going to explore it today. So, chemistry is defined as the study of matter and its phase changes. So, what exactly is matter? Now, matter is anything that has mass and can take up space. Mass is like something that has a lot of weight in it. So, like I remember Mally right here. Do you guys think this has mass? It's pretty heavy?
Mm-hmm.
Yes, thumbs up if yes?
Yeah.
Yeah? Alright, yes. Has mass. And what if I put it on my table here? Do you guys think it's taking up space on my table?
Yeah.
Thumbs up if yes. Yeah, it is taking up space. So this is an example of matter. So, there is 6 phases of matter. But we're going to be talking about the 3 most common. Does anybody have an idea what phases I'm thinking about? Phases of matter. You might see them on a day-to-day basis. Oh, someone said solid. Yes? You heard solid? Alright, solid. What else? Does that maybe click something? What else are the other phases you can think about? You have solid.
Solid.
Yes, my friend in blue? Gas, yes. So solid, gas. We're missing one. Yes. Liquid, yes. Our 3 most common phases of matter are solid, liquid, and gas.
Solid, liquid.
There are 6 in total, but yet again, we're going to be talking about the 3 most common. Let's think of an example on how we see these phases of matter as we can go through them. Oh, yes, my friend here. What do you have to say about our phases of matter?
Ice is solid.
Ice is solid. Ooh, that's a great example. Now I'm going to take that and add cream to it. So ice cream. Right. Who has ice cream under a summer hot day? Today's pretty hot, so it'd be a great day for ice cream if someone wants to invite their mom to ice cream today. So, ice cream is in what phase? Take a guess. What do you guys think ice cream is? Which phase do you guys think it is? When you're eating it? You guys can call it out. Take a chance. Yeah. Solid. Yes, ice cream is a solid. It's in our solid phase. What happens if it's so hot outside and you're not eating your ice cream
Yeah.
quickly? What happens to it? Yes, exactly. It starts to what? It turns into a liquid, yes. So our solid, because of the heat, ice cream starts to melt. And you don't want sticky, melty ice cream. Alright? Now, what's the last phase? What if your ice cream falls on the floor and then you walk away? What do you think happens to that ice cream that's melted on the floor? Yes, my friend?
Slippery.
It will disappear. Why? How?
Slippery. Yeah, so it will kind of be burnt to the ground because of the heat. That's a great way to put it. So after our liquid, because it was so hot that the sun was burning hot to our ice cream, it turned into a liquid. And then because it was left on the ground, like our friend said here, it might have burned. It was added more heat, which means that it could have turned to its gas phase, which means the disappearing part, something that we can't really see. So we're going to explore these 3 different ways and how we move through phases of matter by adding heat and even taking it away. Now, let's go to our first experiment. You guys see my balloons over here? Alright? What do you guys think they're filled up with? Any guesses? Ooh, balloon. Yes? Gases. Gases? Is that what you're going to say? Yeah, right. What type of gases? Does anybody want to take a guess? Yes?
Helium?
Helium. That's a great guess. But we're not going to be pointing to helium today. Helium would be the balloons that go up. This one
It
It's
kinda goes
down.
Think another gas. Something you breathe in. Oh, yes.
Air.
Air? What type of air do you breathe in? You know?
Oxygen.
Oxygen, yes. So there's one gas. Does anybody know which gas we breathe out? Yes.
Carbon dioxide.
Carbon dioxide. We breathe in oxygen and we breathe out carbon dioxide. And then there's another gas that's very a lot amount inside of this balloon. There's lots of gases in here. But our three most biggest ones are oxygen, carbon dioxide, and another one called nitrogen.
Nitrogen.
So these three are inside our balloon as well as a lot of other gases. But we're going to be talking about those three. So if I have our gas-filled balloon here, our atoms and molecules on this chart, can we see how separated they are? They look like they're far away from each other. So that is why our balloon is so inflated, because all our atoms and molecules are taking up all the space in this balloon, just being very far away from each other. So my goal today is, I want to put 3 balloons inside of this pot. You guys think I can do that? Now, some noobs, anybody have no? They disagree with me? Yeah, no, I have some people that would believe in me. All right, I have my first balloon. I'm gonna add my third balloon, and we're gonna see if it fits. Okay, so it does not fit. What about our third balloon? You're taking up too much space. So I'm going to try and do some experimenting with our very cold substance. I'm not gonna tell you what it is because it ruins the surprise. But we're going to test out putting a very, very cold liquid that's gonna go inside of our pots. And I want you guys to talk to your neighbors for just a second and tell me what you guys observed while I pour in our very cold liquid. All right, this one, we gotta pick it up. You can see it's blue. We're gonna pour some inside. I want you guys to just take a note. What do you guys see coming out of this pot? And now we are going to see and test out. Can I put 3 balloons inside of this pot? Yes, you guys believe in me? Yeah? No? Oh, we have some thumbs. Okay. All right, let's try. So here goes our first one. We're gonna squeeze this one right inside. What do you guys see happening to our balloon? Well, this one's a little shimmy. Let's see if it wants to go in. Very slowly. I'm pushing it inside of our pot. Let's see if we can encourage it. Come on. Go inside, because we want to put all 3 balloons in here. Shimmy, 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 shimmy. This one's really fighting. Let's see. Should I push it a bit harder? Yeah? Alright, let's see. Or should we put more cold stuff in it? You think it will help? Yes? I think it will help too. I think we need a little bit more support for our balloons to fully accomplish our goal of making sure our balloons fit inside of our big pot. Okay, let's see now. You guys see that clear balloon? Where'd it go? Does that mean we can fit another one? Let's test it out. All right, let's go pink. Come on, pink. Oh, you look at pink. Can we see it anymore? There goes pink. Can we put orange, our last balloon, in here? Yes, yes, yes?
Yeah.
Oh, yes, we have some believers now. Okay, let's push it inside our very cold, our liquid. And then we're seeing our, ooh, that's a big, ooh, that's a lot. Have they put all inside of our pot? Yes. All right. Cool, cool, cool. So what happened to our gases? So our oxygen, our carbon dioxide, and our nitrogen were put into that very cold substance inside of our pots. So our gases, our atoms and molecules, their heat was taken away, and they're like, oh my gosh, it's cold. I want to get close to somebody so I can get warm. You know, when it's really, really cold, you want to snuggle yourself in bed so you don't turn really, really cold. That's what's happening to our atoms and molecules. And they have been so cold that they're so tight together that they're now kind of coming closer and closer together. Now, what happens when we take them out of our pot? Let's see, we can see what they have done and what turned into. Come on out, orange. And you guys observe what is going on with our balloons. What's happening?
Like,
Ooh, yeah, peek out. It's inflating. It's coming
Yeah.
back up to how it looked like originally. Wow, how is this happening? Alright, we're gonna let pink come out. This should be the show. Alright, see what's happening to pink. And now we have 1 balloon, 2 balloons.
wow.
We're missing how many more balloons in there?
3.
1. Alright, let's see 1. Let's see our first balloon that we put in here. Oh, there goes orange. Alright. I want my people in the front row to please tell me what you guys observed. Because we're going to look at the bottom of this balloon. I want you guys that can really see up here. What do you see down outside of this balloon inside? What does it
Good.
look like?
It's good.
Anybody, what can you see in the far corner right there? It's a little hard to see, but I'm jiggling it around a little bit. Water is a liquid. Yes, what do you see?
And the air is going back in the balloon.
The air is going back in the balloon. It's kind of like taking up that gas phase again. And we mentioned some liquid down here. And there's also kind of this like little chunky piece of ice. I don't know if you can hear it. Let's see. It's kind of crackling, yeah. So we are seeing our phases of matter happen from our 3 gases we talked about. So our oxygen and our nitrogen are that liquid that you see here. They were once a gas, but because we put them in a very cold area, they have turned into the phase of a liquid. Now, our nitrogen, our carbon dioxide, sorry. Our carbon dioxide went quickly from a gas, so quick because of the cold environment, to a little solid. So that's when we kind of saw that little lumpy piece after that liquid. So those are the phases that we saw our 3 gases go through. Pretty cool, huh? Now that we've played along with our inflated balloons, we can throw them out the window. And let's talk about how a regular little old balloon looks like. What can we do with a balloon just like this? Anybody have an idea? What can we do with it? Yes, I found a balloon.
Blow it up.
Blow it up, yes. Oh, we already blown up these balloons. What else can we do with it? Yes. My friend here is dark. What can we do with this rubber balloon besides blow it up? You can do anything. What would you do with this balloon? Take a guess, don't worry. Be anything creative. You can do a lot with a balloon. You can play with it, yes. How can we play with this balloon? Anybody have any ideas? How can we play with a balloon? Yes.
Stretch it.
We can stretch it. Yes, we love stretching. Our balloon has a rubber component, which is rubber. So our rubber balloon can be plated by stretching it. This component of stretching it, and then what happens when we let it go on one side? What do you think happens? It snaps back. All right, that's good. All right. Now our balloon is back to how it originally looked like. So I can stretch this rubber balloon because of a component in it called elasticity. So rubber has elasticity, which is anything that can stretch, but always come back to its original form. Now, this rubber balloon has a lot of stretchiness and elasticity. What do you guys think about our rubber mallet here? You guys think this has elasticity? Thumbs up, no, thumbs down, some thumbs down. Oh, we have up. Up, yeah, maybe. All right. So our friend over here, we have some nose on this side. I would like to agree with my friend that did a thumbs up. This is strange. This can't stretch, right? I can't stretch this out no matter how hard I try. But it's a rubber mallet. So it still has the same component as our rubber balloon, but it doesn't have a lot of elasticity in it. So I can't stretch this per se, but it does have it. Our elasticity is kind of like our solid phase. You see this? It's not a liquid, it's not a gas. You can see it. So it's a solid. So our atoms and molecules kind of look like this. So, do you guys think we can put a rubber balloon versus a rubber mallet? Yes? No? On a rubber mat? We're gonna test, oh yes, we have a hand. All right. So, we're gonna test this out, where I'm gonna put our rubber mallet against our rubber balloon. And I'm gonna try to smash it and see what happens to it, all right? You ready? So 3, 2, 1. Oh. Our balloon, oh, still has some elasticity in it, still stretchy, pretty good. But what if I really, really want to do some damage to my rubber balloon? Do you guys think we should test it out by putting inside our cold substance again? Should get out, yeah, right? That's the cool part, our cold substance. So I'm going to add, again, just some more of our cold substance, and we're going to see that very cool thing happen again while I pour it. So let's put some in. Woo. Let's see. Alright. And I'm going to get my little tongs over here, which I put over there. And we're going to put our balloon, kind of like if we were going to cook some meat. So there goes our dinner balloon. I think it looks pretty good. Now, before I take it out, I want you guys to count to 3 with me when I put it on the map so we can count and put the rubber mallet against it, okay? So, are you guys ready? Yeah? Okay, let's go. So, from a count from 3. So 3, 2, 1. Whoa, what happened? Let's see.
Oh,
Oh, cool. Yes. It broke? Yeah, it shattered. Whoa. Our rubber balloon. Does it look like how we did earlier? No. What happened to our rubber balloon? It's all in pieces. It's shattered. Let's talk about how this happened. So, remember how we said our rubber balloon has elasticity? And it looks kind of like this where all the atoms and molecules are close to each other? We put it in an even more colder situation. So, our elasticity becomes brittle, which means that it's easy to break. So all of our atoms and molecules came so close together that they came too brittle. So when I put our rubber mallet and smashed it, it shattered. Well, yes, my friend here.
A different word for brittle is fragile.
Yes, perfect. Another word for brittle is fragile. Definitely. I use brittle because it became less or weak. And fragile would be when we don't want to break something, so be really careful with it, right? Cool. Vocabulary, amazing. All right. Now, let's talk about the big reveal of what I actually use inside of our pot. And before I can do that, I want to make sure that you guys know that this here is a liquid. You guys see another thing on my table that I've been touching around basically our whole stage presentation? Anything over here? You guys have a guess?
yeah.
What do you think it is? Yell it out loud. Say it louder. It's a liquid, yes. And what liquid do you guys think is inside of it? Yes, my friend? Water. So, what is happening to my water inside of our can right here?
Whoa.
It's warm. Yes. What else do we see? Yes, my friend right here, glass.
Boiling.
It's boiling. How do you know it's boiling? How do you guys know something is boiling? Bubbles, yes. Anything else that makes you know that something is boiling? The steam? You guys, you gonna say the steam? Yeah, you agree? Alright, so yes, we know something is boiling because we see the vapor. Kind of the steam, what we call vapor here. And then our bubbling, which I'm pressing again and again because it's already boiling. So, I have it here on my little heater pot right here so that I can boil my water. Because my water boils at a degrees of 212 degrees Fahrenheit, which is pretty hot. So it takes a while to heat up, and that's why we have it here in our little kind of coffee maker is what I say. I like boiling my water in this for my coffee. Now, over here we have our other liquid. Do you guys think this liquid, which we're going to name right now, is liquid nitrogen? Do you guys think liquid nitrogen is boiling? Yes, no? Oh, we have some no's. No? All right. We're going to see how it looks like in our glass beaker right here. So I'm going to pour some of it inside. And we're going to take some observational notes. What do you guys see coming out of our beaker? Our beaker. Yes?
So, there's gas coming out.
There's like a gas, kind of like that vapor we saw earlier, right? What else do we see? My people in the front maybe have a good eye. What do we see happening to our liquid nitrogen? You guys see some bubbles, bubbling. so our liquid is inside of there. It's bubbling. And you hear that hissing sound? That's kind of like when it whistles over here. Our liquid nitrogen, it has
Awesome.
boiling and vapor. So this means it's boiling. How? If it doesn't have this heat, we didn't put it inside of here. Now, you guys think it's pretty hot in this room? Yeah, it's hot. It's hot out here. It's hot outside too.
Yeah.
So, this temperature of our room is kind of like an oven for our liquid nitrogen. Our liquid nitrogen boils at a degree of negative 320 degrees Fahrenheit, which is so low. Our room here is maybe 70 degrees Fahrenheit, kind of normal temperature, hot, and that's way more bigger than a negative number. So our environment over here is saying that this is hot enough for our liquid nitrogen to boil just by sitting here.
Water?
Pretty cool. Now, our last hope of experiment is, what if we combine two boiling things? You guys want to see that happen? Should we combine our liquid nitrogen and our hot water? Oh yes, we have some thumbs up. We have thumbs up. Yes, finally, my first thumbs up in the first shot. Okay.